You've probably held one of these in your hand thousands of times. It's a simple tool, a constant in our lives, from the classroom to the workshop. It's been with you as you learned to write your name, solved complex equations, and maybe even sketched out a dream in a notebook. It is, for all intents and purposes, an ordinary object. But behind this simple object lies a story of incredible engineering and mind-boggling scale. This isn't a story about just one pencil. It's a story about the estimated 15 billion that are produced worldwide every single year, enough to circle the Earth more than 60 times. This is the story of how raw cedar logs from managed forests and crystalline graphite from deep within the Earth are transformed by a symphony of mega machines into billions of perfect pencils. What you're about to see is a hidden world of automation and ingenuity, all to create something we so easily take for granted. The humble pencil. It's an instrument of creativity, a tool for education, and so common that its existence feels almost like a given. We find them in junk drawers, on office desks, and in the backpacks of students all over the world. But have you ever stopped to consider the journey it takes? How is it possible to produce such a staggering number of these things, so consistently and so affordably? The answer isn't in a small workshop, but inside colossal mega-factories where technology and tradition merge. The story of the modern pencil is surprisingly recent, born out of necessity. Before 1795, the best pencils relied on pure English graphite. But when the Napoleonic Wars led to a British trade blockade, France was cut off from its supply. A French officer and scientist named Nicolas Jacques Conté was tasked with finding a solution. His brilliant idea was to mix powdered graphite with clay, bake the mixture in a kiln, and encase the resulting rod in wood. This fundamental process was so revolutionary, it remains the backbone of pencil manufacturing to this day. Today, that process has been scaled to an almost unbelievable degree. The global pencil market is a multi-billion-dollar industry, valued at over $15 billion in 2023, driven by constant demand from schools and a growing appreciation for analog tools. What was once a craft is now a high-speed, automated spectacle. We are about to go inside one of these mega factories to witness every step of this extraordinary transformation. This is the complete journey of how billions of pencils are made. Chapter 1. The Heart of the Pencil. Wood. The journey of every wooden pencil begins not in a factory, but in a forest, and the wood chosen for this task is critical. It defines the pencil's feel, its strength, and how well it sharpens. For decades, the gold standard has been incense cedar. This wood, often sourced from sustainably managed forests, has a unique combination of qualities that make it perfect for the job. So, why incense cedar? First, it has an exceptionally straight grain. This is vital for manufacturing, allowing the wood to be cut cleanly without splitting or warping. Imagine trying to make billions of pencils from a wood that twists. The waste would be enormous. Cedar's straight grain makes the process smooth and efficient. Second, incense cedar is soft, but not too soft. It has the perfect density to be sharpened to a fine point, without splintering or breaking away in chunks. We've all dealt with the frustration of a low-quality pencil where the wood just flakes away, taking the point with it. That's what premium manufacturers want to avoid, and it all starts here. The pleasant, distinct aroma is just a bonus, a signature scent of a quality pencil. The process starts at a sawmill where massive incense cedar logs arrive. These are colossal trunks that are first debarked and cleaned. Then, powerful saws slice the logs into thick, rectangular blocks known as pencil squares. These squares are a standard raw material, cut slightly longer than a finished pencil to provide a margin for error later on. These fresh-cut blocks are full of moisture, which would cause warping. To fix this, the pencil stock is carefully stacked inside massive dry kilns. Here, over several days, the wood is gently heated, reducing its moisture content to a uniform level. This crucial, time-consuming step ensures the wood will remain stable for the rest of its life. From the kilns, the dried blocks are fed into another set of specialized saws. These saws have incredibly thin blades to minimize sawdust and maximize the number of slats cut from each block. A slat is a thin piece of wood, about half the thickness of a finished pencil and wide enough to make several pencils. But the slats aren't ready just yet. They're passed through a machine that infuses them with wax and a light stain. The wax is a game changer. It acts as a lubricant that makes all the later cutting processes smoother and, most importantly, makes the final pencil easier for you to sharpen. The stain ensures a uniform color, giving the final product a consistent, pleasing look. After this, the slats are inspected, graded, and packaged, ready to be shipped to pencil factories around the globe to meet their other half. The core. Chapter 2. The soul of the pencil, graphite and clay. While cedar provides the body, the soul of the pencil is its core. It's the part that leaves a mark, and its creation is a mix of geology and chemistry. And let's clear up the biggest misconception right away. It is not, and never has been, made of lead. The term pencil lead is a historical leftover from the 16th century when a huge deposit of a dark substance was found in England and mistaken for a form of lead. It was called plumbago. Over 200 years later, scientists identified it as a crystalline form of pure carbon and named it graphite, from the Greek word graphein, meaning to write. The journey of the modern core begins deep in the earth. Graphite is extracted from mines, crushed, and then put through a sophisticated refinement process to strip away impurities. What's left is a fine, dark powder of highly pure graphite. But pure graphite is too soft. It would crumble under pressure. This is where the second key ingredient comes in: clay. Clay acts as a binder, giving the core strength. But more importantly, the ratio of clay to graphite is the secret to a pencil's hardness. This is where the familiar grading scale, with letters like H and B, comes from. H stands for hardness and B for blackness. A pencil with more clay will be harder and make a lighter, finer line. These are the H-grade pencils, favored by drafters for precise lines that don't smudge. On the flip side, a pencil with more graphite will be softer and make a darker, richer line. These are the B-grade pencils, loved by artists for expressive sketching. The standard M2 or HB pencil sits right in the middle, offering a perfect balance for everyday writing. Inside the mega factory, creating the core is a precision process. Giant silos hold the graphite and clay powders, which are weighed out in exact proportions for the desired grade. They're transferred into enormous industrial mixers. Water is added, and giant blades churn the ingredients for hours. The goal is a perfectly homogeneous paste, because any clumps would result in a gritty core that could scratch paper or break easily. This thick, dark, dough-like material is now ready to be forged. Chapter 3. Forging the core. With the graphite and clay mixture perfected, the next stage transforms this soft paste into the strong, slender rods that will become the writing core of billions of pencils. This transformation relies on pressure, heat, and a little bit of magic. It starts with extrusion. The thick, dark paste is loaded into a machine that works like a giant pasta maker. Under immense pressure, the paste is squeezed through a tiny, precisely shaped die, emerging as a long, continuous, spaghetti-like strand. The diameter is meticulously controlled to ensure it will fit perfectly into the grooves of the wooden slats. These freshly extruded strands are soft and fragile, so they're moved into drying rooms where air circulates at a controlled temperature slowly drawing out the moisture. Once they're dry and a bit more stable, a machine chops the long strands into the exact length of a single pencil. Now, for the most transformative step, firing. The cut rods are loaded into massive industrial kilns and baked at scorching temperatures, often exceeding 815 degrees Celsius or 1500 degrees Fahrenheit. This intense heat doesn't just dry the cores, it fundamentally changes their structure. The clay particles vitrify, turning into a glass-like ceramic that binds the graphite particles into a strong, rigid matrix. This is what gives the pencil core its final strength. What went in as a fragile stick of dried paste comes out as a hard, durable writing instrument. After cooling, the cores get one last treatment. They're submerged in a bath of molten wax or oil. This might seem like a small step, but it's crucial for that smooth feeling as a pencil glides across a paper. The hot wax seeps into microscopic pores in the core, lubricating the entire rod from the inside out. It reduces friction and ensures the graphite transfers to the page evenly and cleanly. After this wax bath, the cores are finally complete, ready to be united with their wooden casing. Chapter 4. The Sandwich Assembly. At this point, we have two perfectly prepared components: the stained, waxed cedar slats and the hardened, lubricated graphite cores. The next stage is where they come together in a process lovingly called the sandwich. This is where the pencil truly starts to take shape. First, a batch of cedar slats is fed into a groover machine. With incredible speed, a set of cutting heads carves a series of parallel, semicircular grooves into each slat. For a standard slat, there might be 8 or 9 of these grooves, each one perfectly shaped to be exactly half a home for a graphite core. The grooved slats continue down a conveyor where a nozzle applies a thin, even layer of a powerful, elastic adhesive into each groove. This isn't just wood glue, it's a specialized formula designed to bond with both wood and graphite while staying flexible enough to prevent the core from shattering under pressure. Next, a lead layer machine holding thousands of finished cores is positioned over the belt. As a glued slat passes underneath, the machine precisely places a single graphite core into each groove. It's a marvel of automation, handling the delicate cores without breaking them. Now, it's time to complete the sandwich. A second set of grooved slats, also coated with glue, is flipped over by an automated arm and carefully placed on top of the lead-filled bottom slat. The alignment must be perfect, encasing the graphite cores between the two halves. What emerges is a pencil sandwich, a solid block of wood with multiple cores running through its center. To secure the bond, the sandwich is immediately sent into a high-pressure press that applies up to 1,000 kilograms of force, squeezing the two halves together while the glue sets. This pressure eliminates any air gaps and creates a solid, unified block. Once pressed, these sandwiches are stacked and left to cure, allowing the adhesive to dry completely. This final, solid bond is what prevents the annoying problem of a loose or shifting core in your pencil. Chapter 5. From block to pencil. The cured pencil sandwiches are now solid blocks, each containing the promise of about 8 or 9 pencils. The next steps are a rapid, precise, and mesmerizing process, where high-speed machines carve out the individual pencils. The journey begins at a shaping machine. First, saws trim a tiny amount off each end of the block, ensuring every pencil cut from it will be the exact same length. Once trimmed, the block is fed into the main event, 2 sets of rapidly spinning cutting heads, one above and one below. In a single, deafeningly loud pass, these cutters carve away the wood, transforming the flat surfaces of the block into the familiar shapes of pencils. As the cutters finish, the individual pencils are sliced free from the sandwich, separating from their neighbors for the first time. The most common shape is the classic hexagon. This isn't just for looks. It's a brilliant piece of practical engineering that stops the pencil from rolling off your desk. Other shapes include a simple round barrel or a triangular one for an ergonomic grip. As the newly formed pencils tumble out of the shaper, they're still raw and rough. To prepare them for painting, they need to be perfectly smooth. The pencils are sent through a series of sanding machines that buff away any roughness, leaving the surface silky, smooth to the touch and providing a perfect canvas for the next stage. The speed here is staggering. A single shaping line can process thousands of pencils every hour, turning a heavy block of wood into a continuous stream of perfectly formed, raw pencils. Chapter 6. The Finishing Touches. A raw, unpainted pencil is functional, but it's not finished. The final stages are all about protection, branding, and adding the last few components that complete the pencil's iconic look. This is where it gets its personality. First stop, the painting line. The smooth pencils are fed one by one through a lacquering head that coats each one in a thin, even layer of paint, often a classic yellow. They emerge dripping and are whisked away on a conveyor through a drying tunnel. But one coat isn't enough. This process is repeated multiple times. Depending on the desired quality, a single pencil can receive anywhere from 4 to 10 individual coats of lacquer. Each coat is followed by a trip through a drying oven. This meticulous layering is what gives a pencil its glossy, chip-resistant finish. Once the final coat is dry, the pencil is ready for its brand name, grade, and logo. This is often done with foil stamping, where a heated die presses colored foil onto the pencil. Another modern method is laser printing, which etches the information onto the painted surface with incredible precision. Now for the final hardware. If the pencil gets an eraser, it first needs a ferrule, the little metal band that holds it. A machine cuts a small recess into the end of the pencil, then forms a thin roll of aluminum into the ferrule shape and crimps it tightly onto the wood. The last component is the eraser itself. Small plugs of rubber or a synthetic compound are inserted into the open end of the ferrule. A final press clamps the metal down, holding the eraser firmly in place. With that, the pencil is finally whole, transformed from raw materials into a complete, ready-to-use tool. Chapter 7. Quality Control and Packaging. The journey from raw material to finished product has been long and complex. But before any pencil can leave the factory, it must pass one final test: quality control. Ensuring every one of the millions of pencils produced daily meets a high standard requires a rigorous system of checks. This process is a mix of high-tech automation and skilled human oversight. As finished pencils come off the line, they pass through automated inspection stations. High-speed cameras and laser scanners check for flaws in milliseconds. Is the paint finish perfect? Is the branding clear? Most importantly, is the graphite core perfectly centered? An off-center core is a major defect that leads to uneven sharpening and breaking. Any pencil that fails is instantly rejected. But machines can't check everything. Batches are also pooled for manual testing. Technicians will sharpen pencils to check the wood quality, perform writing tests to ensure the graphite is smooth, and even conduct strength tests to see how much pressure the point can take before it breaks. This human touch is the final guarantee of quality. Once approved, the pencils are ready for packaging. Some may first be sent to massive industrial sharpeners that put a perfect point on thousands of pencils a minute. From there, other machines count and bundle them into packs of 10, 12, or by the gross. These bundles are fed into boxing machines that assemble the boxes, insert the pencils, and seal them up. The finished boxes are then packed into larger cartons, stacked onto pallets by robotic arms, and loaded onto trucks, ready to be distributed to stores, schools, and offices all around the world. So the next time you pick up a pencil, take a second to really look at it. Consider the journey it took to get to your hand. It started as a cedar tree in a forest and as a lump of graphite rock from a mine. It was sliced, ground, mixed, extruded, baked, glued, pressed, shaped, and painted by a symphony of incredible machines, all working in perfect harmony. The creation of this simple tool is a testament to human ingenuity, a story of chemistry, engineering, and industrial might. It's a process that turns raw, natural elements into a precise instrument for ideas and creativity. Billions of times over, the humble pencil is a quiet reminder that even the most ordinary objects can have an extraordinary story. What everyday object should we explore next? Let us know in the comments, and thanks for watching.